just going to do some reviewing of some of the fraction things we've been working on. So first, we're comparing fractions, which means we need to get the denominators the same. So looking quickly at this screen, right away I see this one right here. They both have a 6 on the bottom, so I don't need to do anything to them. So I'm just going to say 5 6 is more than 3 6. So that means I didn't have to change any denominators. Sometimes I only have to change one. So I'm looking for a number. Can I take 6 times something to get to 8? I can't. So that means I'm going to be cross-multiplying butterfly up here. So first step is I'm taking 6 times 8, which equals 48. That's going to be my new denominator for both of my fractions. And then since this is cross-multiply butterfly, we're going to get a wing right here. 5 times 6 is 30. So what we're saying is 5 eighths is really the same as 30 48ths. Really all we did was just take both of them times 6, that number on the bottom. Here's my other wing. 8 times 4 is 32. So I got 32 48ths and 30 48ths. 30 48ths is going to be less than. 7 is the smaller denominator. Can I take 7 times something to get to 11? I cannot. So we're cross-multiply butterfly. I'm getting a 77 for both denominators from 7 times 11. Make my left wing first always. 3 times 11 is 33. And 4 times 7 is 28. 33 77ths would be larger. 4 is my smaller denominator. Can I take it times something to get 8? I can. So 4 times 2 equals 8. And this denominator already has an 8, so I'm not even going to have to touch that side. Since I took this times 2, I'm also taking this times 2. So 3/4 is the same as 6 eighths. And 7 eighths is more than 6 eighths. Nicole ate 6 eighths of the pie. What fraction is left to eat? Nice simple problem. It says it's a pie. I'm going to cut it in 8 pieces. Because it's Nicole, I'm going to put an N on all of the pieces she ate. 3, 4, 5, 6. And then what fraction's left to eat? Well, anything that's not Nicole. So 1, 2, 2 out of 8 in all. Kenneth ran 1/5 of a mile. What fraction is left to run? This is exactly the same kind of problem as the pie. So I could draw it as a pie. I can draw it as a loaf of bread. So I'm just going to do a loaf of bread. Kenneth ran 1/5, so I cut it in 5. I shaded 1 for Kenneth. What's left to run? 1, 2, 3, 4. 4 out of 5. Since this one's miles, I'm going to go ahead and say it. Guess I should really just say mile. 4/5 of a mile. John painted 3/4 of the room. What fraction of the room is left to paint? Same exact kind of problem again. So I just need to divide it into 4 equal pieces, because that's what my denominator said. John painted 3 of them, so I'm putting a J on 3. What's left that's not a J? 1 out of 4. So 1/4 of the room is still to paint. This time I'm adding some fractions. And adding fractions is easy because I just add the numerators. So 5 plus 6 is 11. Denominator don't do diddly, which really means it just stays the same. So I got 11 eighths, but this is an improper fraction. So I need to convert it to a mixed number. Easiest way is to take the 11 eighths and just make a container that holds eighths. And then I'm going to start putting things in. I've got, because I have 11 of these eighths. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 of the eighths. I need another one of those containers that hold 8 because I still got some left. So there's 9, 10, 11 eighths. Now I just put down what is full. So I have one whole full one here, and this one is 3 out of 8. So when I put those together, it equals big 1 and 3 eighths. Try this one with fourths. 3/4 plus 3/4 is 6/4. Doesn't matter what shape I make my containers in. And I went ahead and made the second one because I know this is over a whole one. 6/4 has got to be over a whole one. So 1, 2, 3, 4, 5, 6. So that equals 1 whole one and 2/4, which is the same as 1 1/2. Down here, 3/4 plus 4, 3/5 plus 4/5 is 7/5. So I'm making one cut into fifths. This is the one that I usually tell the kids looks like a starfish because you got the head and 2 legs and an arm. Actually, I guess I should say it looks like a sand dollar because that's how they really look. 1, 2, 3, 4, 5, 6, 7. one whole one right here in front, and then 1 2 out of 5. So 1 2/5. Here I'm trying to make an equivalent fraction. So I'm going to be, since I'm changing this denominator, I can do this a couple of ways. I can draw this with 4/5, as long as I draw it like a loaf of bread and shaded 4. I'm going to go get a different color here. And the kids know this is the chainsaw method, because now I'm taking this 4/5 and I have to cut horizontally. So now that's 1 2 3 4 5 6 7 8 out of 10. We're trying to get to 30, so I'm going to have to keep cutting. There's 12/15, 16/20. Got to keep going. 20/25. One more time. There's my 30th. I'm now cut into 30 pieces, and I've got 1 2 3 4 5 6 times 4, 24. If you didn't want to do the chainsaw method, you could just go like this. What am I taking the 5 times to get to 30? 6. And whatever we do to the denominator, we also have to do to the numerator. So if the kids can handle multiplying, in fact, I would rather them do that than the chainsaw, because I think it's easier. So up here I'm taking what times 2 equals 12? 6. And if I take 6 times 2 on the top, I'm taking 6 times 3 on the bottom, which gets me to 18. Down here, some people go, hey, you got a number out front missing. It doesn't really matter. We're going to do the same kind of thing. What times 5 equals 15? 3. So I'm taking 3 times the number we don't know yet, and it equals 9. It's going to be 3. 2 fish, 4 cats, 1 bird, 3 dogs. For people who need to visualize a little bit more, I take this and just say, okay, so there's my 2 fish. Put F's for fish. There are 4 cats. 1 2 3 4 C's. 1 bird. 3 dogs. If you happen to get one where the words start with the same letter, you can just do something else. I could have drawn the picture of the fish, the cats, the birds, and dogs, but I kind of felt like it would have taken a long time. What fraction are dogs? So I'm counting the dogs. I got 3 out of 1 2 3 4 5 6 7 8 9 10. 3 out of 10. What fraction are cats? 1 2 3 4 cats out of 10 in all, because my denominator is not going to change. Fraction of birds? 1 bird out of 10 animals in all. And fish? 2 fish out of 10 in all. This problem with the colors is just like what we did with the animals, so I'm going to make 3 G's. There's my 3 greens. 5 blues. 1 2 3 4 5. And 1 big old orange. What fraction are blue? Notice you got to read carefully, because they don't always do them in the right order, right? I don't even know that there is a right order. I got 5 blue out of 1 2 3 4 5 6 7 8 9 in all. What fraction are green? 3 out of 9 in all. And what fraction are orange? 1 out of 9 in all. Weight of kittens in ounces. So we got Spike, Boots, Mittens, and Scratchy. How much more does Spike weigh than Mittens? Right away I see my clue words, much more minus. Every time it's much more, I know it's going to be subtracting. So I got Spike is first. He's 5/6 of an ounce minus Mittens is 4/6 of an ounce. Subtracting fractions is easy because I just do whatever the numerator says. 5 minus 4 gets me to a 1, and the denominator stays the same. How much do Scratchy and Boots weigh together? Together tells me I'm going to be adding this time. And I got Scratchy, which is 3/6, and Boots, which is 2/6. 3/6 plus 2/6 gets me to 5/6.